This is the example we are going to solve. So consider the function f of x equal to x square minus 2x e to the power minus x plus e to the power minus twice x. Okay, so we are going to uh, find the solution, which means that f of x equal to 0 within 10 to the power minus 5 by using Newton's method first and then by applying the Aitken acceleration. So that is our problem, and that we need to find a solution of it. But before I move on to solve the problem, let's note some points. You already know about these points, but still I'm just refreshing your mind so that we don't misunderstand the solution or any other aspect of the problem. So when you say within 10 to the power minus 5, so we mean that it will be here 5 decimal point. Okay, so that means uh, to find a solution within 5 decimal point, it means that we need to keep in our calculation up to 6 decimal point and round it off to 5 decimal point. And if it is less than 0.00001 or 10 to the minus 5, then we are done. Okay, now the problem or question is the following. When you say find the solution within 10 to the minus 5, what do we mean? We need to find that f of x equal to 0. This result will be 10 to the minus 5. In other words, if the value of f of x will be less than 10 to the minus 5, that is what we mean. Or with respect to the root, the x star, and then the xk, our iterated value, the difference between these two will be the minus less than 10 to the minus 5. Which one? Because these two may not be within the bound all the time simultaneously. It is usually not the case. Okay, so let's move on further. If it is f of x equal to 0, that is what we are looking for. That means we are looking for the solution of f of x equal to 0 within the minus 5. This means that after iterations, whenever we reach f of xk is less than 0.000001 within 6, because we need to give 6 decimal point or 5 10 to the minus 5, for k is the iteration number, then we say that within that bound f of xk is approximately 0 because it is less than 10 to the minus 5. So anything 10 to the minus 5 will be treated as 0. That is the upper bound of the error. Now, so that is the one case, and if it is the root that we mean, then it will be that absolute value of x star minus xk. Xk is the sum iterated value. The difference between these two will be less than 0.00001. Okay, so that is actually the case we considered during our video lecture. Whenever you know the value of the root exactly, then this is the case you can choose. And but in most of the cases, whenever the root is irrational number or it cannot be solved by analytical method like transcendental equation or anything else, then you cannot compute the difference between the root and the iterated value. It is impossible to compute. Okay, that's why it is not very useful, but and that's why the numerical method comes in. Whenever x star it cannot be computed exactly or it is a rational number, then the point occur how many decimal point or within what error bound we need to find a solution. In that case, numerical method is the only way to solve the problem, and in that case we have to compute the iteration until f of xk, the value of f of xk is within the bound. In that case we'll get it, we consider it to be 0 and xk is our root. Okay, that is the case. So that is the example we are doing here, because this equation f of x equal to the this equation is cannot be solved analytically. Okay, so the root here is not a easy number, it is a rational number. So that means the way we solved during our video lecture, uh, we use a simple example where x star was 2, so that's why we compare with the x star. But in this example we have to compute the f of x after every iteration and check if it is within the bound, and then we continue the iteration. Once it is within the bound, we stop, and that is our solution. I hope everybody is clear what it means. So, but in general, for numerical method, we mean f of x cube to be 0. That is what we're looking for. Okay. So whenever x star is unknown or irrational, that is the case. Okay. Okay, let's move on. So what we do, we have here f of x, our by and f of x we already know. Okay, so from here we compute first f prime of x. Okay, so if we take the derivative of f of x, then we find easily that it is really equal to twice x minus twice x to the power minus x minus twice x times minus e to the power minus x, and then minus 2 times to the power minus 2x. Okay, or if you can simplify easily. So that means from here, using these two, we can compute our iteration formula. So iteration formula is by Newton's method, of course, will be x k plus 1 equal to xk minus f of xk divided by f prime of xk. Okay, that is the Newton's method iteration formula, and if you put it here, uh, then we can write that our formula is x k plus 1 equal to xk, and then minus, let me write the expression here, x k square minus twice xk e to the power minus xk, and then plus e to the power minus twice xk divided by this formula here, twice xk minus twice e to the power minus xk plus 2 xk e to the power minus xk, and then minus 2 e to the power minus twice xk. This is our iteration formula. So k is the iteration number here, k is the iteration number. So what we do in the next slide, we start from initial value like k equal to 0, we call it x0, we pick a point, and using this iteration formula, and then we compute x1, x2, x3, okay, and for each iteration point we compute f of xk. If it is within the bound, we are done. If it is not, then go to the next iteration point. That's how we'll continue. So we present our result in a table. So our starting point is x0 starting point will be x0 equal to 1. That is all we choose. That is for k equal to 0 iteration. Okay. Now let's draw the table. Your first row, first column is iteration number k, and then you compute xk, and then we compute f of xk, and then we ask the question, is f of xk is less than 10 to the power minus 5. Okay, so and If it is no, then we go to the next iteration. Yes, we stop. Okay. So first, now k equals 0. So k equals 0 means x0 is 1, which is here, x0 1. So I can write it 1 here. Now we put this x0 equal to 1 into our iteration formula in the previous slide that you already know. And you can use a calculator, or you can use some software, Mathematica, Maple, whatever you like. And you can uh, put in the values and write down your answer. So our answer first, f of xk will be 0.39956. Now you can look at here, I'm keeping 6 decimal point. Why? Because we need to answer within 10 to the power minus 5. So I keep 6 decimal point, and so then you can round it off. If 5 decimal point is 0.00001, we are done. That's the idea. And definitely it is, this value is not less than 10 to the power minus 5. So answer is no. So we continue and next iteration. So now k will be 1. So this will be x1. Okay. What is our x1? So we can compute the that is the function of the iteration point x1. So we can write plug in the value x equal to 1 there. And then you can find that it will be 0.76891. Okay. And then for this value we compute the function. Even this is the given function f of x. Okay. And that is the x. We put x equal to 1 here in the original function given, then that is the value. And this value come here from the iteration. So we put x0 equal to 1 in the iteration formula, we compute x1. Okay. That is it. And now we put this value here, that this value into this function here with x1 equal to that value, then you get f of x1. Therefore x1 will be 0.09392. Definitely it is also no. Okay. And then we compute the second iteration point, then it will be 0.6644590, and f of x will be 0.022532. Answer again, it is not within the bound. Okay. And then third iteration point, so then we have a value that, remember that I'm repeating again, this third iteration point 0.615033. Where does it come from? I put this x2 here into the iteration formula, I get x3. Okay. And then I put this x3 here, which is 0.615033, into the formula here, a function f of x in the given function, then I get f of x3. That means, let me write it here, this will be f of x3. Remember, this will be equal to 0.005537. definitely it is also no. I compute fourth iteration point, and then you get 0.5908884. Again, that will be f of x3, sorry, f of x4, fourth iteration point, which will be 0.001372. Again, it is also no. Okay. So we'll continue the. So I am running. Let me write it again. So I erase it. It will be k xk f of xk, and that is f of xk is less than 10 to the power minus 5. So here is our columns. So we did up to 4 iteration. Now is the 5 iteration. So I write it here. So fifth value is 0.578963. Then it will be f of x5. Remember, this fifth iteration, it will be 0.000342. Again, it is no. And then sixth iteration point, so here it will be 0.57305. 0.41, it will be 0.000085. You can see we are getting close, but it will even remember this one number is actually when you round it off 9 times 10 to the power minus 5, so it is 9 times higher than the bound, so it is still no. The seventh iteration point, so 0.570089. Remember that how do I got this number from this number? So I put this value into the iteration formula and then get this value x7. Now I put this x7 into the formula of f of x, that is the given function. I get f of x7, which is here 0. Actually I'm writing the exponent form, 2 times 10 to the power minus 5. Again it is no, it is double than that bound. So I need to go one more iteration, 8 or maybe 2, I do not know, let me see, check. 0.568615, and if you compute the value, it will be 0.5 times 10 to the power minus 5. This is half of the bound, definitely. So it is, answer is yes. So you are done. So you stop our iteration. That means, so we can see that f of x8 is approximately equal to 0. Why approximately 0? Because this value is less than 10 to the power minus 5. Within 10 to the power minus 5 means we will treat all value less than 10 to the power minus 5 as 0. So that means this one is our solution here. Okay, that is our answer. But actually if we use Mathematica, Mapper or MATLAB, you can put this function and you find our solution. The x star exact value is called Lambert function. Let me write it, Lambert function, W function with value 1. Okay, and this value is of course the rational number, is really approximately equal to up to 6 decimal point. I'm writing it 0.5671143 up to 6 decimal point. You can see that this is not even close to our the x8, but if you compute, let me write it here, side note, that x star minus x8 magnitude, if you subtract them, then what do you get is almost approximately equal to 1.4 times 10 to the power minus 3. Look at here. So that will clarify our initial question, which one you mean. So our solution is within 10 to the power minus 5, but the difference between x, the root x star minus x8 is not within 10 to the minus 5. So if you want to find the answer within 10 to the minus 5 for the x, not function of x, then we have to do many more iterations. Okay, so you need to understand very clearly that if the actual root value is not computable, meaning irrational or unknown, then you always go by this f of x equal to 0 within the limit or not. Otherwise we have to we will be problem. Okay, so that is the solution of the problem by Newton's method. Now what we do, we apply Aitken acceleration for the same problem and find the solution. Remember that Aitken acceleration